Hi everyone, this is Soumya Paul and welcome back to our DSA series. This is day 3 and today we'll quickly see what is time complexity. Now, let me ask you something. If two people solve the same problem on LeetCode, why does one solution get accepted and sometimes the other fails with something called as time limit exceeded, also very popularly known as TLE, time limit exceeded? Well, the reason is very simple because this solution is not highly efficient in respect to time complexity. Now imagine this. You are searching for a name in a phone book. There are two ways to do this. Either you check every name one by one, or you directly jump onto that name using alphabetical order. Now both works, but which one is faster, which one is smarter? The second one is faster. Now this brings us to time complexity. Time complexity answers one simple question. How much time does my code take as my input grows? Not actual seconds, but number of operations. So let's say you have an array of 5 elements. You loop through all the elements once. So the number of operations is 5. But if array has 100 elements now, then the number of operations will be 100. So time increases with input. Why? Because the number of operations increases with input. So what do we have? We have more time. More time means more work, and by work I means more number of operations. And this means more time. Okay. And this is what is called time complexity. Now when we come to space complexity, this answers how much extra memory does my code use. So for example, if we use just a few variables, that is very less space. But if I create another array of size n, that is more space. So more memory usage means higher space complexity. Now here's where things get interesting. You can either trade time for space or space for time. Use extra memory, which means faster code, or use less memory, which means slower code. Okay. So think of it like this. You have money versus time. You can either spend money to save some time, or you can save money but spend time. Same concept. Okay. So in interviews, you often have to decide which is more important, whether space complexity or time complexity. And interviewers don't just check whether your code is working or not. They check how much can you optimize your solution. Is it efficient or not? The interviewers will always ask you that, okay, you gave a solution. What is the time complexity of the solution? What is the space complexity of that solution? And if they think that there isn't a more efficient solution available with a better time complexity or a better space complexity, then they will ask you to think on how you can improve this even more. Okay. So from the next video, we will go deep dive into the big O notation, something called as big O notation. Which is actually how we measure time and space complexity. Okay. So see you all in the next video. Don't skip this part, and please keep practicing, keep studying. And if you want to have a much more deep dive into these concepts, then do join Code Kados.